Okay, everybody, we're going to be working on our Chapter 2 exercises, and I'm going to start with the first set of them. I'm just going to give it just a couple clicks of zoom here so we can read those numbers a little better. So I'm working on Part 1. For those of you that might not happen to have the book yet, I do have the programming exercises embedded into the actual exercise itself. So, and it's basically just a copy and paste from the ebook of just the exercise section. So you can actually feel free to do that if you don't have the book yet, but you should get the book because you're really missing out on a lot of stuff by not having it. All right, so just so you know. The other tip that I'm going to give you is always look at the directions that I have here. And initially on an intro-level programming course such as this, I kind of do a little bit of hand-holding on some of this stuff to make sure that you guys are not like omitting the steps that you really should be taking as you're working. And after a while, you won't even think about it anymore, and it'll just kind of be an automatic. But as people that are starting out in the field, I kind of like to guide you on what I think is a good workflow. So the first thing I always do is I always do file management first, always. So, and I noticed that my first bullet here is create a folder for the Chapter 2 Part 1 exercises. So that's what I'm going to do. I'm going to bring up a file folder here, and somewhere, well, that's not the right one. You know what, I'm just going to get a new one on screen here. And of course it goes to screen number 2. So here it comes back over. And then I'm going to go to my Google Drive where I store all my Python work for this class. And then I have a folder for this semester. And you see I already have a Chapter 2 folder, right? And I do have a thing in there, that's my example file, and that's not really the one I want to worry about. But this is Chapter 2, and I noticed that Chapter 2 actually has 2 separate sets of exercises. So I'm actually going to make a subfolder in here, and I'm going to call it Chapter 2 Part 1 in kind of my own abbreviation. You know, that's up to you how you name it. And then I'm going to go into that folder, and this is where I'm going to put the first batch of exercises. Right? When it comes time to zip them and submit them, I know where they all are. All I have to do is zip that folder. All right. The other thing that you might want to do is go ahead and open up a Word doc or a Google Doc, whatever tool you choose to use. I'm just going to open up regular Microsoft Word here, and I'm going to create a blank document. And you might want to put your name on the document or something like that. But I'm just going to say homework Chapter 2 Part 1, maybe have your name on it, etc. And then I'm ready to copy and paste stuff in. I can make it look pretty later. All right, so I do have my Spyder IDE open, but I also need to get an exercise description from the book. And I do have the book open here, and I'm going to go to back up one level here and find the programming exercises, end of chapter exercises, and programming exercises. All right. The first one I have to complete is 2.1. So my directions are these. Now watch what I do with this. And this is, you know, frankly, it's kind of goofy, and you don't have to do this. But when I work with ebooks, sometimes I do this so I don't have to flip back and forth. It's kind of cumbersome. So I'm just going to take that and actually go ahead and, well, actually, why don't we close all these old programs here. And here's a fresh one, right? Up here in the comment area, you know, I guess you could leave the time code and all that stuff in there. I'm actually just going to paste in the description of what I have to do right there. That way I don't have to flip back and forth, and I can see it right in front of my face. All right? It says write a program that displays the dimensions of a letter size 8.5 by 11 inch sheet of paper in millimeters. There are 25.4 millimeters per inch. Use constants and comments in your program. So now that I have this new file created, what's the very first thing I should do?
Create comments.
Well, well, I guess, you know, that I probably shouldn't have done that first. But really, what should I do? Save it. Right. You know, I should have pasted the comment in after, but I should save it first. So I'm going to go ahead and go up to File and choose Save As. And then I want to find that folder that I just created, so I know it goes in the right place. And you can see I have Chapter 2, Part 1. That's where I'm going to place it. And this is exercise what? Exercise 2.1. And I'm just going to call it X2_1. And if you want to give it a descriptive name, I suppose you could say inch to mil or something like that. That's what I'm going to call mine. And then I'm going to add py at the end for Python, and we're going to hit save. All right. So we are given certain pieces of information as givens. All right. So we're working with a sheet of paper that happens to be 8.5 inches wide. So here's how my brain thinks about this stuff. I know that if I want to declare a constant, I symbolically use all capital letters for a variable name. And what's the width of the paper in inches? 8.5. What about the height in inches? 11. Are there any other constants given? Mm-hmm. What's that?
Millimeters per inch.
That's right, millimeters per inch. So, you know, a useful name might be something that really explains what it is. So, mm per inch. That way, if I'm looking at this thing in code, I know right away what it stands for. I don't even have to guess. So, the number we were given was 25.4. So, because I named those variables all with uppercase letters, we assume they're constants. Here's the problem with Python, though, folks. We can actually change those. In Java, I would have to declare a number type and that it's a constant. I would actually have to say const space decimal, maybe, or double, and use uppercase letters. That's a convention. But these are implied constants because we named them all uppercase. So as a programmer, we try not to change those if we can possibly help. So now we have to figure out how to convert each one of the measurements that we have to millimeters. All right. So that actually it's a pretty easy thing. So what I'm going to do is I'm going to declare a new variable for each one of the things above. So the width in inches, now we need the width in millimeters, right? So what you might actually want to call it is width underscore mm. Just giving you an idea here, right? And we're going to set that equal to, how do we figure that out?
Take the millimeter per inch, or your mm per inch,
Yeah.
and you multiply that by the width, so you're multiplied by the width inches.
Right. That's correct, David. So we're going to take the width in inches and multiply it, so we use the asterisk, by millimeters per inch. If we want to figure out the height, we do the same thing. So we're just going to say height underscore mm equals, and notice how I'm like opting to do like copy pastes rather than retype. That might be one approach that you use. But then again, you're also using a hypothetically smart IDE. And some IDEs, as you start typing, like I'm typing right now, you notice this one's not doing it. So it's kind of my way of testing it. Will automatically fill in the blank for you. So as soon as you start typing some of the letters, it'll fill in the blanks. Those are higher level IDEs will typically do that. But notice once I do have it typed in how it color codes and matches everything, so you know that right, it's a match. All right, so we did our math, and now we need to do what? Print out.
Our equation, our formula.
Right, so what is it asking us to do? Write a program that displays the dimensions of a letter size, 8.5 by 11 inch sheet of paper in millimeters. So we don't have to like get the distance from corner to corner, right? That's not the thing here. We're just trying to convert these both to millimeters. So what we're going to do is something like this. And I'm going to use some of the output stuff, the formatting commands that we were just talking about in the lecture. and you can say it any way you want. I'm just going to say the paper is, and then I want to format it. Okay, so I want to think about this, and I want to format it in terms of millimeters, right? So I'm probably going to have something like, you know, whatever it works out to be, I'm going to have the letters mm in there for millimeters. But there's some formatting I can do using some of the techniques that we were taught. I'm going to use a wildcard to start because I don't know what the first digits are going to be. And then, do I care how many places the millimeters display?
Do you want?
Yeah, I mean, I think, you know, if 8.5, well, if 1 inch equals 25.4, chances are we're going to need the decimal point. That's kind of the way I'm thinking of it. So I think maybe one decimal place is adequate. So I'm just going to do this. So I'm going to say %1.1F, so only one decimal place, and then millimeters. And then, you know what? We're giving dimensions, right? So what I'm going to do is I'm going to say by %.1F millimeters. And then here comes that percent sign here, but that's got to go, we got to actually separate this out. So this is telling us that we're applying the formatting here. And notice I have two formatting commands. So that means I have to have two things I'm sending to it. And the two things I'm sending to it, and these have to go inside, by the way, these have to go inside parens, is width millimeters, comma, height millimeters, like so. All right, I'm going to do a Control S to save. And let's go ahead and run this and see if it actually works. So I'm going to hit the play button. All right. The paper is 215.9 millimeters by 279.4. All right. You know, I guess, I'm not really sure, you know, but we assume that's right, okay? But here's what you might want to do. And this seems kind of silly since you just programmed the computer to do the math for you to sit here and double check the math. But you know what? It's a good idea to double check the math, folks. So you know that it worked out right. Because if it didn't, guess who's going to be squawking about it? Your instructor. So if I have 8.5 times 25.4, there you go. And then 11 times 25.4. Okay, we're good. All right. So it wasn't an accident that I put one decimal place in there. I kind of knew the answer already. But like if you were guessing, you might have put something higher in there. But it's not a bad idea to have your calculator handy and do that kind of thing. Now, of course, if I'm doing this for homework, right, which I guess you guys all should be, I'm going to kind of arrange my screen here, sort of like this, so my output is easy to see, my program is easy to see, and then I'm going to bring up my snipping tool in Windows. So I'm just typing, I hit my Windows key and I just started typing SNI, found the snipping tool, I press enter, and then I'm going to click new, and then I'm going to come here and I'm going to grab, I guess I'm going to be kind of strategic here, grab all this, and you know what, just enough to show the output. That's fine right there. I'm going to copy that by hitting the little icon up here, or you can do Control C. I'm going to go over to my Word doc, wherever that is, paste it in, and right above it I might say exercise P 2.1. Maybe I'll throw in some comments. This was a piece of cake, no problems. All right, that's just an example of how you might do your work. Remember, the important thing is when you're doing these screenshots, if you're ending up with stuff that you can't read, can you imagine, like, my older eyes probably will be complaining. So if you see your fonts getting too small in the screenshots, then split your screenshots up. Maybe take the code shot separately from the running. That's up to you. I mean, it'll be kind of subjective. That'll tend to happen more on high resolution screens, though. All right, that's an example. I'm going to move on now to the next exercise. I'm not closing any of those windows. I'm just minimizing them because I know I'm going to have to come back to it. Now I want to go back to the book and look at the next one I have to do, which is exercise 2.3. All right. So this program, and this one says, write a program that reads a number and displays the square, cube, and fourth power. Use the double asterisk operator, which is for exponents, only for the fourth power. So you can't use it for a square and a cube, which you might be tempted to, right? All right, so once again, I'm going to copy all that. I'm going to paste it in to my IDE just so I have it handy. All right, I'm going to go ahead and create a new file. First thing I'm going to do, of course, you guys know the right answer now, is save it. This is exercise 2.3, and this is, I don't know, what do we call this one? How about to the power? I can't think of a good name. All right. Once again, I'm actually going to take those instructions for the exercise and I'm going to paste them up here. Remember, that's an optional step. I just do it so it's easy for myself. Yes?
The second part?
This is exercise 2.3,
Oh, okay.
which is part of the first set of exercises. All right. So I have it in there, and now I'm going to start doing my coding here. All right, so this should be pretty simple, I think, but it is asking us to read a number, and you know what? This is one of the tricks, right? You guys would have, if you already completed this homework, that means that you read ahead farther than where I lectured, so you figured out how to read a number, because where are we reading a number from? From the user, folks. That's what that means. We're going to read in a number from the user, so that means we need to create a prompt. So here's where I'm going to start. All right, I might say something like, if you want to put comments in, you can do this. You could say, read the number from the user. And then what I would do, since I know I'm reading in a number, I might just create a variable called number. I'll issue the input function. And from there, I'm going to type in the following command. And then I'm going to give you a couple of foods for thought here, food for thought. Right, so I'm going to type input, and then here I'm just going to ask the user enter a number. And notice I'm leaving a space there at the end, like before the double quote, like right here I'm leaving a space. And the reason I'm doing that is when I type the number in, it won't be touching the colon. It will have a little breathing room. Okay? All right. The one thing that we learned in the book is right away you should be converting that number, right, into whatever it is that we need it to be, right? Because when I read it in from the keyboard, it's what? It's a string, okay? So the way that we would do that is, typically I would actually create another variable, and I would say num2 equals, and then I use the float command to convert number. Okay, so I can do it that way. Right? And you know what? I expect that most of you probably did it like this. And you know what? That's quite all right. All right? So I'm going to give you an alternate way to do it, though, after I do the display part of it, because now we're going to do that. So let's display things. And the first thing we'll do is we're going to issue the print function, because that's how we display things. And we're going to start with the number that we converted, num2, and then we're going to throw in some text that makes sense. So num2 squared is, or if you want, you could say equals. I think that would be fine too. And then what would we output? What do I have to throw here? How do we square? Oh, you just take num2 times num2, right? That's how you would square it. You know what? Before I go any further, I want to test this before I write the other stuff. Let's go ahead and save this and just do a preliminary run. Okay. And somewhere here, oh, okay, it's right at the bottom of the screen. It's asking me to enter a number. Now, I made an interesting choice here, because I didn't say enter a whole number, which is why I chose to choose float for the conversion and not an integer. The other issue is sometimes when you square things, it messes with the decimal place as well. So I chose float intentionally for a reason. So I'm actually going to put in like a weird number like 2.5. Okay, and press enter. 2.5 squared is 6.25. Is that true? Calculator, where are you? Right here. So 2.5 times 2.5 equals, okay, my math is good. Okay, so we know that's working, correct? All right. So let's move on to cubing, which, you know what, shouldn't it be almost the same? A cube, of course, is multiplying a number by itself 3 times, so I could just multiply it one more time, right? And we got to change this text, of course. Say cubed. And then, of course, if we're doing it to the 4th power, right? Instead of doing, multiplication, I could just add one more multiplication, right? But what I should optimally do is really do this. Num2 to the 4th power, which is multiplying against itself 4 times. And I want to change my text as well and say to the 4th power. Let's save this and run it. And I'm going to use, I'll use a different number this time. So let's do 5. 5 squared is 25. 5 cubed is 125. And to the 4th power is 625. All right, so I did have the question here in class, and I had paused the video, that couldn't I have used the power symbol to do these other ones? Yes, but the instructions say that you should only use it for the 4th power. It also shows you basically what powers are. It's always multiplying a number against itself how many times. So instead of writing num2 times num2 times num2 times num2, I can just say num2 to the 4th power. And that's basically the point. Another little trick I'd like to show you guys, and I'm just going to alter this program a little bit just to show you the result. And actually instead of, instead of like typing it all out, I'm just going to pull this over, because I often, like when I'm doing these videos, I have a solved version on the other screen that I bring over, to guide my work. And this is a different approach that you might opt to use. Notice how they did the input on this. They did the input, but they placed that input directly inside of a float function, so they grabbed the input and converted the number all in one step. Advanced programmers tend to use that sort of an approach because it eliminates one line of code. It's functionally doing the same thing, but it's not spelled out twice. So which approach you choose to use, either one is fine. I would guess, because you were following the book, you guys probably use this approach, but an advanced programmer might opt to do this approach instead. And that's perfectly okay. I just want to show you that it saves the creation of one variable, and every time you save the creation of a variable, you know what that does? That's less memory used, which means your program operates more efficiently, right? And then your system has more resources to do other tasks. So those are the kind of things you look for making programs more efficient in the long run. All right, our next exercise will be exercise number 2.4. And I'm going to take a moment here to pull that one up on the screen. And I've got to find my browser window, though. So 2.4. All right, so this one's a little more interesting. Seems like it has a few more steps. So notice what it says. It says, write a program that prompts the user for two integers and then prints the sum, the difference, the product, the average, the distance, the absolute value of the difference, the maximum, which one's bigger, and the minimum. All right, and they have a little hint. Python defines max and min functions that accept a sequence of values, each separated with a comma. Now we're only doing this for two integers, folks. So we have a little bit of work to do here. You know what? And it's probably not as bad as you would think. So I'm going to jump over to the IDE. Of course, create a new file. Got our pattern going now, right? First thing we do is save. And we're going to call this exercise 2_4. I can't think of anything creative else to add to it, so I'm just going to leave it at that. And the first thing we need to do is get the input from the user. So we're going to ask the user for two numbers, right? I'm going to need somewhere to store those numbers. You know what? I'm going to call my variables A, right, and B. Maybe A and B works pretty good. I think that's pretty good. A and B. All right. I know they're incomplete lines so far. I know I'm going to do the input statement, and I'm going to say enter an integer. All right. And you know what? That's going to happen twice, right? My advice to you, though, is I would also indicate, so they know it's a different prompt, enter another integer, so they know it's two different prompts. I know that this is going to come in as text and needs to be converted to a number right away. Why not do the conversion right away? Let's get in that habit, because you know what? I think it's a really good habit to be in. So I'm going to just put that whole statement in an integer function. And notice I built the prompt first and then I wrapped the integer around it. So it's going to grab it from the user and then it's going to convert it to a number right away. All right. Our next step and the stuff that we need to compute is this stuff. So I'm just going to copy and paste it from my other screen here. So we have to display the sum, different, product, average, distance, minimum, and maximum. All right, so we can go straight to print statements for these folks. So that's what I'm going to do. So a sum is pretty easy, right? What does a sum mean? Adding it together. So I'm just going to do like a little chart. I'm going to say sum, and then I'm going to do a comma, and I can just add them together, right? A plus B. We can do the difference. Comma. Well, that's easy. A minus B. Keeping in mind, if somebody types in 5 and then they type in 10, it could be a negative number. Okay. All right, let's do the product, which is multiplying. So A times B. See, this is a piece of cake, right? This isn't so hard. Oh, it doesn't go to division next, does it? No. Now we got some challenging math. From here we go to average. Oh my God. You might actually have to look up how to do an average. You guys remember how to do an average? Well, you add all your values together first, We only have two numbers, so that's easy. All right? After you add all your numbers together, you divide by the number of numbers that you have. In this, our case, 2. So you might be tempted to write your equation like this. And fair warning, not the way to write the equation, because what will happen first is that b will get divided by 2 first and give you the wrong answer. So you actually have to put in a second set of parentheses here. You need to do the addition first before you do the division to get the right answer. If you don't believe me, let's do an example in the calculator. If I put in the number 5 and then the number 10 and then I divide by 2, I get 7.5. That's the right answer. It's right in between 5 and 10. However, if I didn't have the parentheses in there, what would happen first is the 10 would divide by 2, and then I would add the 5, and I would get 10. That is the wrong answer. That's an example of why parentheses matter. Okay? And that's why it's also good to have that calculator handy whenever you're doing math to make sure you're getting the right stuff. Next thing that we have to do is we have to print the distance. Okay, so the distance per the book is the difference without a positive or negative sign. Now we already learned this earlier today. There's a special function for doing that. What's the function? Absolute value, ABS. And what we're looking for is A minus B. We're looking for the absolute value of that. So if it ended up being a negative value, it cancels out the negative. So if I subtract 10 from 5, I end up with negative 5, but the distance between them is 5. All right. Next thing that we want to do is we want to get the min and the max. And let's stick with capital letters here. And then a comma, and then we can just use the min function, and now we just feed the variables in one at a time. There's no math involved. It looks at the list and figures out which is more, which is less. So the first one we're doing is minimum. The second one we're going to do is maximum, and then you only have to change a couple little things to make that work, like so. And folks, this should be the entire program. I'm just checking the description in the book. Sum, difference, product, average, distance, maximum, minimum. Okay, I think we're good. Let's go ahead and do a Control S to save, and then I'm going to go ahead and do a run. All right, so I'm running. All right, and you can see my prompt down here. It says enter an integer. I'm going to use the numbers that we've been working with because I kind of know what the answers are going to be now because I've been playing with it in the calculator. So I'm clicking in there to make the window active. I'm typing in 5. My other integer is 10. And then it gives me all the answers. Is the sum 15? Yes. Is the difference negative 5? If I subtract 10 from 5, do I get negative 5? Yes. If I multiply together, I do get 50. We already proved the average is 7.5. The distance between the two is definitely 5. And then the minimum number is 5 and the maximum number is 10. Okay, got it all to work. Not a problem. That is exercise 2.4 completed. Okay, we're going to move on now to exercise 2.8. So I'm going to bring that up on my screen here. Okay, so this one says, write a program that asks the user for the lengths of the sides of a rectangle, then print the area and the perimeter of the rectangle, and then the length of the diagonal. There's going to be some math involved here. You know, maybe enough where I might even copy this text over. So I'm going to copy it right out of my ebook. Let's go back over to Spider and create another new file. Doing a save as immediately. This is exercise 2.8. Exercise 2_8. I'm coming up with not clever names anymore, so I'm just naming it like that, .py, and saving. Inside the top comment section here, I am going to paste that problem description, just so I have it handy, and then we can start writing our code. All right. So once again, we're going to have to ask the user for length and width. And I want to put out a couple of things here, because this isn't going to be too hard, frankly. Because you know what? We already have a thing where we're asking a user for inputs, right? And converting to numbers. And we can just kind of like copy that and change it a little bit. Yeah, why not? Let's do that. Let's save a little time. Now, I got some thoughts about this, though. They are not asking for integers, right? So we're asking for the lengths of the sides of a rectangle. So my thinking is, instead of calling this A and B, I'm going to call one length and call one width. Does that seem to make sense to you guys, right? One side of a rectangle is long and one is wide. You know, I don't know how. You know, I suppose you could say dimension 1, dimension 2. That could be a thing. So I'm also going to change my wording here, and I'm going to say enter the length of the rectangle, and then the other one I'm going to say enter the width of the rectangle. You gotta spell it right, though. I guess, you know, technically I guess you don't. Now the other thing I'm thinking about is, how are they entering this? Right? What length? What width? Is this going to be like feet and inches? Is this going to be like metric? Is it going to be like counting numbers only? You know what? Frankly, I don't really know. So instead of like converting it to an integer, I'm going to opt to convert it to a float. Because my thinking is, somebody might say, well, that's, you know, 5.5 miles wide. It's a really big rectangle. And they might enter 5.5. You see like my thinking here? So I think a float is a better conversion than an int. Could you do it with an int? Yeah. You know, would I downgrade you for it? No. I'm just telling you how my mind thinks. Because we're not really specifying the size of the rectangles we're dealing with. So I'm going to go with float. So I have my inputs, and I'm storing them in variables. I'm doing the conversions right at the same time, which I think is a really efficient way to work. All right, let's move on and do some of the math. Now, unlike some of the other stuff where we were doing the math in the output statements, I'm going to tell you as a programmer, I don't think that's always a good idea. Sometimes it's better to do the math, store the result in a variable, and then output the variable. So here's how I'm going to proceed. I know that one of them is the area and the perimeter of the rectangle. Let's start with the area. Okay. How do you determine the area of something that's got a rectangular shape? You multiply the length times the width, right? Correct. That's exactly how you do it. So I'm going to multiply those two together. That's one piece of math done, piece of cake. The perimeter, well, what is the perimeter? The perimeter is the length of all the sides added together, right? And because we have a rectangle, the two long sides will be the same length, and the two short sides will be the same length. So really all I have to do with that is I can just take, all right, well, let's create a variable for it to store it first. So the perimeter is actually going to be the length times 2 added to the width times 2. Now, question for you. Do I need parentheses around this? No, because the multiplication will happen first anyhow. If you wanted to be on the safe side, put parentheses around the multiplications. You know? But I know that the order of operations will make multiplication go first, so this will be the right result. The next thing that we need to figure out is the length of the diagonal. And then I say to myself, oh, wait a second. hello Pythagoras, right? You guys remember the whole Pythagorean theorem, the a squared plus b squared equals c squared thing? And even if you don't, the way that you figure out the length of that diagonal is you add a and b squared together, that gives you what c is, and then you have to take the square root of that. So now, wait, I need the square root thing, so now I have to add a math library to my program. So here's what I'm going to do. First line of the code, the actual line of the code, so above all this stuff, since I'm going to be typing in an import statement, I need to put it right at the top. So I'm going to say from the math library, import sqrt for doing square root. All right? So now I can come down here and get this information in there. So I know ultimately I have to get the square root, but we got to do a squared plus b squared first, right? So a in our case might be length. I might say length. And you know, here's what I could do. I could do powers. I could go length to the second power, right? Or I could just say length times length, right? Same difference, folks. Then I'm going to add it to width to the second power. Now I'm going to tell you, because this is a power, I might actually get rid of these extra spaces. That might read better, I'm thinking. And this is just a visual thing. Now that whole thing, that's my a squared plus b squared. That equals c squared, but then I have to get the square root of that to get the right value. So this is where I put my sqrt for square root. And now, folks, all the math is done. Now all I need to do is put this stuff up on the screen. So we're going to do a series of 3 print statements. And you know, I'm going to be a little efficient here. This is based on laziness, mind you. All right, so I just created 3 and copied them, so I don't have to type them all. And then the first one we're going to figure out is the area. The area is, and then we're going to comma area. The perimeter is, comma, perimeter. And then finally, the diagonal length is, comma, diagonal. Now, I have a little bit of a thought though, and I'm going to probably come back to fix it. And that last one might have kind of a messy output because we're doing floating point math and we're getting square roots. It'll probably have like some value that goes out to like 20 digits. So I might come back and format that one. But for now, I'm going to call this done and see if it works. So I'm going to do Control S to save, and I'm going to hit the play button, and I'm going to start with a prompt. So first prompt is enter the length of the rectangle. Now I'm going to put in some numbers I know work, and so we can see the answers. So the length of the rectangle is 3. Oops, 3. The width of the rectangle is 4. How long is my diagonal, by the way, with those numbers? All right, you guys haven't done math in a while. I know it's going to be 5. Isn't that interesting? All right, so is the area 12? 3 times 4 is 12. Is the perimeter 14? 3 plus 3 is 6. 4 plus 4 is 8. 8 plus 4 is 14. Good. What's the square root of a squared plus b squared? 3 squared is 9. 4 squared is 16. Add them together, that's 25. The square root of 25 is 5. Okay. Now that worked out pretty because 5 is a nice round number. But what if I run this again and I put in numbers that aren't quite so pretty? So for example, I put in like 25.89 or 132.2. Oh my God. It starts throwing like errors at me. You guys seeing this? So what it's doing is it's kind of choking on the fact that it can't really, oh, did I changed something. See what happened? I typed my numbers over here, not over there. Let's try that again. Save.
You gotta put the L and A, you know. Right?
Thank you. Yes. There we go. Okay, save it. Let's run that again. You just got to make sure you click over in the console window before you start typing in numbers, right? All right, so now it gave me something that's a little more normal. But the diagonal length, do I really care about all those decimal points? Frankly, no. So what I am going to do is I'm going to throw in a little formatting here. And right in this spot, I'm actually going to do a percent. And I think 2 decimal places is fine. And instead of the comma, then we put in the percent sign and save it. Let's run that one more time. And let's try some, kind of messy numbers. And now our output looks a little bit more reasonable. This video ends here.